You're welcome to Physics Clinic. In this video, I will be discussing radioactivity. In 1896, a French scientist called Henri Becquerel discovered radioactivity when he placed a uranium salt called pitchblende on a photographic plate wrapped with paper and placed inside his drawer. The next day, on developing the photographic plate, he discovered that it had become blackened without exposing it to sunlight. So he was wondering where the light that blackened the photographic plate came from. Further investigation shows that the light that blackened the paper came from the uranium salt. Years later, another scientist called Maria Curie discovered another radioactive element called polonium, which she named after her native land, Poland. She and her husband, Pierre Curie, both discovered more radioactive elements. They discovered radium and thorium. She later discovered that the radiation coming out from these newly discovered radioactive elements are more intense than the one of uranium salts. So she named this phenomenon radioactivity. What is radioactivity? Radioactivity is the spontaneous disintegration or decay of unstable nuclei by the emission of alpha particles, beta particles, and gamma radiation with the release of energy. Now, Sir Ernest Rutherford discovered that there are three types of radiation that are emitted during radioactivity. He named them alpha particle, beta particle, and gamma rays. So what are the properties of this radiation? For alpha particles are made up of 2 protons and 2 neutrons. So they look much like the nucleus of helium. So we can refer to them as helium nuclei. So alpha particles are helium nuclei. They are positively charged. They are positively charged particles. They are slightly deflected in a magnetic or electric field because they have more mass than beta particles and gamma ray. They have the least penetrating power, so they can be stopped by a piece of paper. They have the greatest ionization effect. For beta particles, they look much like fast-moving electrons. So we can refer to them as fast-moving electrons. Since they are electrons, they are negatively charged. They are more penetrating than the alpha particles, so they can pass through a piece of paper but can be stopped by aluminum plates. They have less ionization effect. They are strongly deflected in electric or magnetic field. And gamma rays are electromagnetic waves, so they are not deflected by either electric field or magnetic field. They have no mass and they have no charge, and they have the greatest penetrating power, so they can penetrate paper and aluminum plates but can be stopped by thick lead block, and they have the least ionization effect. This diagram shows the behavior of these 3 radiations in electric field. So here, when a radioactive source is allowed to emit radiation, we see a particular radiation coming out without any deflection in this electric field. And this radiation that comes out undeflected in the electric field is what we refer to as gamma ray, because it's having electrical property, so it cannot be deflected by electric field. Also, if it's in a magnetic field, it will not be deflected by magnetic field because it also has magnetic property, and we refer to it as being electromagnetic in nature. But alpha particle is slightly deflected in this electric field and is deflected towards the negative plate of the electric field, indicating that alpha particle is a positively charged particle, while the beta particle is strongly deflected in the electric field and is deflected towards the positive plate, indicating that beta particles are negatively charged. Here, this diagram shows the penetrating ability or power of the radiations as it comes out from the source. Now, coming out from the source here is alpha particle. When it gets to this paper, it is stopped by this piece of paper. So the radiation that is stopped by a piece of paper is alpha particle. Another radiation that comes out, represented by this straight line, passes through this paper but stopped by the aluminum plate. So it is definitely beta particle. But there's another radiation that passes through the paper, penetrates through aluminum plate, but stopped by thick lead block. And we refer to it as the gamma radiation. Gamma radiation has the greatest penetrating power. That's why it can pass through paper and aluminum plate. So how can we detect the radiation coming out from a radioactive material? Number one, with the use of Geiger-Müller counter or tube, Geiger-Müller tube. Sometimes we call it the GM tube. Tube. So Geiger-Müller tube can be used to detect alpha particle, beta particles, and gamma rays. Another detector of radiation is the photographic plate. Photographic plate. We can also use the diffusion cloud chamber. Diffusion cloud chamber can be used. And number 4, the scintillation tube. And number 5, we have the semiconductor detector. etc. There are more radioactive detectors, but here I've listed 5. Number 1, Geiger-Müller counter or Geiger-Müller tube, or sometimes we refer to as GM tube, can be used to detect the 3 radiations. We have photographic plates, diffusion cloud chamber, scintillation tube, and semiconductors detector. Thank you.